Wow, there is a fire. So many people are getting hurt. I can see some people are doing artificial respiration. But actually, why do we need to do artificial respiration to help those whose life is in danger? How can this help them?
Haha, I've heard of a good question. Hi, I'm Dr. X. Nice to meet you. And I'm going to answer your question. But before this, we need to know what is inhalation and exhalation.
Huh? What's that? I've never heard of them.
Inhalation just means breathing in the air into your lung. So the prefix in means breathing in. And exhalation just means breathing out the air from your lung. So the prefix ex is like exit, going out.
So when we are doing artificial respiration, we are actually helping the patient to do inhalation and exhalation. But why do we need to breathe? It seems breathing is so important to us.
Actually, we are getting something which is useful to our body from the air during inhalation. And then we release some waste to the air during exhalation. But what are they? You should have learned this. Or you have already given all the things back to your teacher? It is about the respiration in cell, which can also be called cellular respiration.
Can you tell me what are they?
Haha, then let me remind you about the word equation of respiration. We need oxygen and glucose to carry out the respiration, and we can get energy, carbon dioxide, and water afterwards. The cells need energy to work, so we need to intake enough oxygen and glucose to carry out the respiration. We can intake glucose from food, and we can intake oxygen from the atmosphere. While on the other hand, carbon dioxide, which is the product of the respiration, is also useless, because we don't need them, so we just release them to the atmosphere.
I remember the word equation. So we are breathing in the oxygen for respiration and breathing out the carbon dioxide which is produced by the respiration. Am I right?
Yes, you're right. And during artificial respiration, we are actually helping the patient to get oxygen. But then it comes to another question. How do we breathe in our daily life? We do not need the artificial respiration.
It's so easy. It's because of our lung.
Then let me ask you another question. Let's imagine our lung as an empty bottle which can hold some air. But can the air flow in or flow out by itself without any external forces?
It seems so difficult because the air only moves randomly around.
Yes, you are right. So if we want the air to flow in or flow out, we need to create a difference in air pressure inside and outside.
Is it because air will always flow from the high pressure to a low pressure?
Yes, it's just like when you're standing in the train, which is very crowded, but if you see the next carriage is very empty, some people will move towards that carriage so that they can have more space until the crowdedness of two carriages is similar.
So if we want to breathe in air, it means we need to make the pressure inside the lung lower than that at the atmosphere. But can our lung change the pressure inside by itself?
Don't worry, There are two kinds of muscle to help it. There are the intercostal muscle and also the diaphragm muscle.
I know them. The intercostal muscle are the muscle between the ribs, and diaphragm is beneath the lung. But where is the diaphragm muscle?
Diaphragm muscles are at the peripheral area under the diaphragm attached on the rib cage.
Oh, I see. But how does the muscle contraction contribute to the pressure difference between inside and outside?
During inhalation, the diaphragm is originally dome-shaped. When the diaphragm muscle contracts, it pulls the diaphragm downwards to make it flat. The intercostal muscles also contracts, and it pulls the rib cage upward.
I don't understand how can it pull the rib cage upward. Isn't it located between the ribs? Then how can it pull the rib cage upward?
Let me borrow a tool to explain for you. Here is the simulation model of the rib cage. There are several stakes. The longest one on the right-hand side is spine. Another vertical stake on the left-hand side is the sternum. And the two in the middle are the ribs. The string connecting between the two ribs is the intercostal muscle. When the intercostal muscle contracts, it will shorten. So I will later gently pull the string to simulate the contraction of the intercostal muscle. Let's see how it goes. So you can see as I pull the string, the ribs start to move upward and outward. You may take a look on it one more time.
Therefore the volume of the lung will increase.
Nearly correct. The volume of the thoracic cavity will increase first, and it will contribute to the increase in the volume of lung. And when the volume increases, the pressure will decrease. So do you know what will happen?
Therefore the pressure inside the lung will be lower than that of the atmosphere, and air will flow into the lung from the atmosphere. Am I right?
Excellent. Can you start from the beginning to tell me the whole story?
The intercostal muscle and the diaphragm muscles contract. The volume of the thoracic cavity increases, and the volume of the lung also increases. When the volume increases, the pressure inside the lung will decrease. So the pressure inside the lung will become lower than the atmosphere. So the air flows into the lung.
It seems you have a good understanding on what is happening during inhalation. So can you guess what will happen during exhalation?
It seems a bit difficult to me. Hi, I know you are smart. Can't you help me?